Alright, by now you're probably pretty good with factoring, and even with solving equations that are set equal to 0, but this one's a little bit different. But we start out the same way. So we've got a polynomial on the left side, trinomial, and we can factor it into two binomial factors. And then from there, we need to continue to solve it. Well, I remember that if I have a binomial times a binomial that's itself, then I can write it as a single binomial squared, raised to the power 2. And then we can introduce what's called the square root property. And the square root property says for any number n greater than 0, so for n greater than 0, if we have a value squared equal to that number, then we can isolate that value so that it doesn't have a square anymore, as long as we take the square root of the number on the right side and also do the positive and negative of that number. And it's a helpful property, definitely, but it didn't make sense to me. It wasn't a clear process, just jumping from a value squared equaling a number to getting plus and minus the square root at the other side. And so I thought about it and tried to figure out why it made sense. And that's what this video is all about. It's about how I discovered the relationship that's being used in the square root property. So for our problem, we have x minus 3 squared. So our value squared is x minus 3. And in order to solve an equation, we're always trying to isolate x, right? So to get x by itself, we first have to get x minus 3 by itself. And that's what the square root property says. So it would tell us to say, okay, we can write x minus 3 equal to positive, negative, square root of 36. And then we could continue going on and solving the equation. But I'm going to show you why it makes sense to go from this step to this step, to fill in all the holes. Because to me this is a shortcut, and shortcuts are great, but they're not great until I know why they work. And then I can use them all I want. But I like to understand that math isn't magic, that it makes sense, that there's a reason, there's a relationship that's being skipped over here. One important concept to remember is that every positive real square number has two roots, a positive one and a negative one. So for example, 16 has two roots. It has 4 and negative 4. And the reason that that's true is because both 4 times 4 equals 16 and negative 4 times negative 4 equals 16. But then the question is which root should be used, which mainly should we use? And it became the convention to use the positive root, and we even gave it a name called the principal root. And we even have a symbol that is used to identify that the principal root is the desired root. So, for example, when we see this symbol around 16, even though it is true that negative 4 times negative 4 equals 16, the answer by definition is positive 4 and only positive 4. Negative 4 would not be correct, even though it is a root of 16. It's just not the defined principal root. So now the problem that we had originally is the square of something more than just a number, or rather it's a number squared, not just a single number like 16. So instead of looking at 16, let's look at 16 written in its perfect square form. So the square root of 4 squared. My pen will write. So the first root of 16 is 4 squared, and then our other root of 16 is negative 4 squared. Now let's look at both. Well, the square root of 4 squared, That's the same as the square root of 4 times 4, which is 16. And the principal root, that is a positive root of 16, is 4. Then we have the square root of a negative 4 squared. Well, a negative 4 times a negative 4 gives a positive 16. So again, we have the square root, the principal root of 16, and that is 4. Well, this actually reminds me of the absolute value function. If I take the absolute value of 4, which represents distance, I get 4. And if I take that negative 4, I also get 4. Both 4 and negative 4 are exactly 4 spaces away from 0 on a real number line. Okay, well, then I could also say that the square root of 4 squared is the same as the square root of negative 4 squared. In each case, both are equal to the absolute value of 4. Now let's take an unknown value, some arbitrary x, and do the similar thing with it. So x squared, and we're square rooting it. Well, I don't know what x is. It's an unknown variable. So there are two cases that I have to look at. If x is positive, then the principal root of x squared is x. Just like when we did the principal root of 4 squared, we ended up getting 4. And if x is negative, then the principal root of x squared is opposite x, or negative x. And that's just like when we took the square of a negative 4 and then took the principal root, we got its opposite back as the answer. Well, this is really cool because this is the important relationship. The square root of an unknown x squared is equal to the absolute value of that unknown. And the absolute value covers both cases, the positive and the negative. And this is what we're going to use to help finish our problem. Now remember, we were trying to fill in the gaps of how we get from this step to this step. And so using our new relationship, which I've put underneath the square root property over here, square root of x squared equals absolute value of x, that's what we're going to do. So we're going to take the square root of both sides. So what you do to one side, you have to do to the other to keep balance of an equation. And that brings, according to the relationship over here, the absolute value of x minus 3 on the left. And then on the right, by definition, principal root of 36 is the positive root, or 6. And then from there, the definition of absolute value says that we have two cases. We have either x minus 3 equals 6, or x minus 3 equals negative 6, opposite 6. Well, that, if I put those into one combined sentence, would be just what we've got at the bottom, because whenever you've got the left side being the same, we've got x minus 3 and x minus 3, I can do plus minus to cover the fact that this is a positive and this is a negative 6, and put my 6, which is exactly, if we take the principal root of 36, what we would get there. So we filled in our gaps all the way up to there. Using the square root property and the shortcut, we would get to the same place that we did following through using the absolute value relationship. But we aren't quite finished, so let's go ahead and finish the problem. The sandwiched equation we've got down here is clear to solve if we break it into two equations So I'm going to do that. And then we need to get x all the way by itself, all the way isolated. And we can add 3 to both sides. And we have x equals 9 for that one. And over here we have x equals -3. So for my solution set, I would write -3 and 9. And it would be wise to check my solutions as well because I may have made a mistake. To save time, I just checked them and you can see that both the -3 and the 9 work. And the shortcut definitely helps us solve problems quickly, but I like knowing why the shortcut works.